This lesson deals with supplemental problem 3.9. You can find this problem in the ECE201 ebook in the Chapter 3 Supplemental Problems on page 9. Given this circuit, let's find the current I sub x using a Thevenin equivalent circuit. The Thevenin equivalent circuit is a two-step process. First we remove the load, and we find the open circuit voltage, and then we find the resistance looking back into those terminals with all the independent sources set equal to 0. So let's do the first one. Remove the load, and let's find the voltage between these two terminals. I have two resistors here in series, and they share the same current. I could use the voltage divider rule. Since they're equal, I'll have half of the 10 volts, or 5 volts. Here I have a 2 amp source, and it can only go into the 5 ohm resistor, so I'll create a voltage of 10 volts. Think of this as a common connection or ground. The voltage from here to the reference, and from here to the reference is known, so I could take their difference and get the value. 5 volts minus 10 volts is V Thevenin, which is minus 5 volts. I set all the independent sources equal to 0. That's a short for a voltage source and an open for a current source. I have 10 in parallel with 10, share the same two nodes here. And that's just 5 ohms, and then all that's in series with 5 ohms, so I get 10 ohms. So my Thevenin equivalent circuit, with the plus sign of the Thevenin voltage near the terminal A, let's find the voltage from A to B, and the minus nearer at B, and the value would be minus 5 volts, and the Thevenin resistance was 10 ohms. Now if you don't like the minus sign, you could put it the other way, as a plus and minus plus 5. Now the current that flows in this direction is going to be 5 volts divided by 16 ohms. I want the current in the other direction, so this would be the negative of that. It turns out to be 312.5 milliamps. And this is supplemental problem 3.9.